For the final exam review, I'm going to break this up to 3 videos since it's the last and final review or item that we're going to be doing before the final. You guys can break this up over a couple days and work on it, but I do suggest you work out each problem with me. It is not a grade in the grade book, but it will help you with the final. It's set up just like the final. So it is in your best interest. Okay, so let's get started. So for the first part here, this will be Unit 5, and that was linear systems. So for the first one, I see that I have a negative 1y and a positive 1y, so I can use elimination method by eliminating these, and then I would combine straight down. So 3x minus 7x is negative 4x, and 2 plus 6 is 8. 2 and 6 were both positive, so I just added them. To get x by itself, divide by negative 4, and x would be negative 2. So it's got to be B, C, or D. To get the second part, the y value, I look to see what is the best one to plug this negative 2 into, the first one or the second one. Now I say they're both pretty even, so since I have a positive y, I'm going to go with the second one. So this is the second equation, and I'm going to plug that negative 2 in for x right here. So this would be multiplied to be positive 14, and then I would subtract 14, and 6 minus 14 is negative 8. So I'm looking for negative 2, negative 8, which is letter C. Okay, and number 2, I just want to know what is the solution of this. So the point of intersection would be 1, 3. So that would be D. Okay, in number 3, it says find the solution of the linear system. So when I look at this problem, I see that I have a y by itself. For this, I would use substitution method. And I could use that 2 ways. I could do the step 1, 2, and 3 like I did in class with you guys. Also, in our notes for Unit 5, there was a very small section that explained that you could plug the points back into here to see if it would work in both equations. And it has to work in both. So I'm just going to do both of them so you can choose what method you like. Okay? So step 1 for substitution method said pick the equation that has x or y by itself. And that would be the second one. Y is by itself. Step 2 says pick the other equation. Okay? You take the expression from step 1. So this expression equals y. So you plug that into y. So the x and the 6 stay the same, but y is replaced with positive 4x minus 4. So here I can combine like terms. So 1x plus 4x is 5x. And then I have a 2-step equation, so I add 4. And I would divide by 5, so x is 2. Now, if x is 2, has to be either A or C. Okay? So now I go back to step 1, step 3. Go back to step 1. I take x is 2, and I plug it in for x. And then I simplify. So 4 times 2 is 8. 8 minus 4 is 4. So this would be 2, 4, which is letter A. Okay, now, if you want to do it the other way, okay, you basically pick a point like 2, 4, and you know that that is x and y, and if I plug it in to both equations that are listed, each side of the equation has to equal each other, and it has to work in both. So if I were to plug in 2 for x, 4 for y, does 2 plus 4 equal 6? Yeah. Okay, that's good. But it has to also check out in this one as well. So I plug in 4 for y, 2 for x, and we get 4 equals, 4 times 2 is 8. Does 8 minus 4 equal 4? Yes. So since this point works in both of these equations, we get the same number here. Basically the equations balance out. Then it's a solution. And you can just circle it. 2, 4 is your answer. Okay, number 4. For this one, I'm going to zoom in a little bit. If you are able to print it, I do suggest you print it, the graph at least, because you can kind of, if you highlight where the y-axis is, it does help take your eye to the right locations of the lines. So, for example, I see that this dashed line is going right here, and that's where x and y meet. So x-axis and y-axis meet at 0. So I know that this dashed line is going to be a 0. Okay, the y-intercept is 0. The other line meets way down here at -7. So this one's going to be -7. Okay, now, in class, we had a chart, and we also discussed that if you had a less than or a greater than that had no line, these were dashed. But if they had lines, they were solid. So the top one here that I started with the 0, it's dashed. And we see that the shading is below or under, down. That's less. So no line. And if we look at possibly like right here, we see that that works at a nice, neat point. So from this point to this point, what's the slope of the dashed line? So we go up 1, 2, 3, 4, over 1, 2. So 4 over 2 is really 2x plus 0. So I'm looking for 2x plus 0. Okay? And I even have the less than right. Okay? Oh, sorry. You see it right there. Okay. Then, for the last one, I could use that same point in this case, because it's a nice, neat intersection. So from here to here, I would go down 1, 2, 3, over 2. And this has a solid line, so a solid line has the equal to part. But I see that that dark shading is under that line. So again, it's less than. So I'm going to double check. I see that it matches this one and this one. But we already know that that one's a match as well. So that has to be D. Okay, number 5. Looking at each one of these images here, are you able to tell which one is no solution, many solutions, or one solution? So one solution is where the two lines would cross, meeting at one point. So this is 1. No solution would be where the two lines are parallel. They're never going to meet. So you can see right here, these are parallel. And many solutions is actually two lines on top of each other so that every single point matches, which is many. Okay, for number 6, for this one, you are to match which graph it goes with. So, if you are able, again, to print off a graph, I highly suggest you print off a graph. I'm trying to find a graph real quickly here. Okay, so we're gonna graph it on our own graph paper, and then we're gonna match it. So for the first equation, we're going to start at -4, And it says go up 1, right 3. And down 1, left 3. Okay, then the second one starts at positive 4, but it says to go down 7 and then right 3 because it's positive. And we obviously can't fit any more points on the graph. So if this is what my graph should look like, I'm looking at each one of these and seeing, okay, does that look right? Like that starts at a positive 2. I need to start at a positive 4, so that can't be it. Look at this one. We can see that the lines aren't matching up there. Look at this one. Okay, did we start at a positive 4? Yes. They met at 3, negative 3 also. Started at negative 4. Yeah, so C has to be my solution. Okay, my other thing that I would do if I didn't have a graph to print, I know that that first one starts at negative 4, so I would go graph that on every graph. Okay, it touches the line barely, but it's not on the line, so that can't be it. That can definitely not be it. And then this one, it's on the line, so I would go, okay, well, if I start at negative 4, can I go up 1 over 3 and still be on the line? I can be. Same thing here. If I start at positive 4, I see I'm on the line. If I go down 7, right 3, again, I'm on the line. So you could do it on here. It's just harder because I know we're on the computer. So, you know, if you're able to print, it would make a little bit easier for you to get through. Okay, number 7, find the solution of the system. So this will not have a graph on it. It'll just ask you, what is the solution to this? Okay? So you're supposed to know that, oh, well, these are 2 vertical and horizontal lines. And so your answer would just be x is negative 2 and y is 3, which means your answer is B. But if you don't understand how that visually looks, if you go x is negative 2 and you draw your vertical line, and you go y is positive 3 and draw your horizontal line, they meet right here. That's negative 2, 3. That's your point of intersection. All right, so that's the end of Unit 5 review material for the final.